Hi everyone, and welcome to Sleep and Learn. Tonight, we gently drift into the vast and quiet universe, where galaxies take on the most unusual and fascinating forms. Far beyond our world, there are galaxies that glow like rings of light, others that stretch and twist as if shaped by invisible hands, and some that are so faint they almost disappear into the darkness. These strange galaxies are not mistakes of the universe. They are part of its natural beauty, shaped slowly over billions of years. In this journey, we will explore what makes galaxies strange, how they form, when they shine the brightest, and why they matter in understanding the cosmos. Each part will reveal a new layer of this calm and mysterious story, told through light, time, and gravity. So take a deep breath, relax, and let your mind wander through the silent expanse of space, where even the strangest galaxies move in perfect harmony. What makes a galaxy strange? In the vast, silent ocean of the universe, galaxies drift like luminous islands of stars, gas, and dust. Most follow familiar patterns, graceful spirals, soft glowing ellipses, or scattered irregular forms. Yet, among these cosmic structures, there exists a quieter, more mysterious category: strange galaxies. These are not simply rare, they are deviations from expectation, places where the usual rules of cosmic architecture seem to bend, stretch, or gently dissolve. A galaxy is typically defined as a gravitationally bound system containing billions or even trillions of stars, along with dark matter, gas, and dust. Under normal circumstances, gravity shapes these elements into stable and predictable forms. However, strange galaxies emerge when this balance is disturbed or when unusual conditions guide their formation. They may appear distorted, unusually bright, unexpectedly dim, or structured in ways that seem almost artistic in their unpredictability. What makes a galaxy strange is not chaos, but subtle complexity. Some galaxies stretch into long tidal tails, like streams of starlight pulled across space. Others glow intensely at their centers, powered by supermassive black holes that quietly consume surrounding matter. There are galaxies that barely form stars at all, drifting in a calm, dormant state, while others burst with rapid star formation, shining with youthful energy. The origins of these peculiar forms often lie in interaction. When galaxies pass near each other, their immense gravitational forces begin a slow and silent dance. Over millions of years, they may pull, twist, and reshape one another. This process, known as galactic interaction, can create rings, bridges, and elongated arms that extend far beyond their original boundaries. In some cases, two galaxies may merge entirely, forming a new structure that carries the memory of both. Time plays an essential role in shaping these strange galaxies. Unlike sudden events on Earth, changes in galaxies unfold over incomprehensibly long periods. What appears as a frozen, unusual shape is often just a moment in an ongoing transformation. A distorted galaxy today may become smooth and stable billions of years later. In this way, strangeness is not permanent. It is a phase, a gentle transition in the life of a galaxy. There are also galaxies that challenge our understanding through their composition. Some contain very little visible matter, making them faint and difficult to observe. Others are dominated by dark matter, an invisible substance that reveals itself only through its gravitational influence. These galaxies remind us that what we see is only a small part of what exists. Interestingly, strange galaxies are not always distant or rare. With modern telescopes, astronomers have discovered that unusual structures are more common than once believed. The universe, rather than being uniform, is rich with diversity. Each strange galaxy offers a quiet story about the forces that shaped it: gravity, motion, time, and the unseen presence of dark matter. When we observe these galaxies, we are not just looking at distant objects. We are witnessing processes that began billions of years ago, long before our planet formed. The light reaching us has traveled across immense distances, carrying with it the history of transformation and change. In a calm and reflective way, strange galaxies invite us to reconsider what is normal. They show that variation is not an exception but a natural outcome of a dynamic universe. Their unusual forms are not mistakes, they are expressions of cosmic creativity, shaped by the same fundamental forces that govern everything we know. As we continue to explore deeper into space, more of these galaxies reveal themselves, each one adding a quiet layer to our understanding. They remind us that the universe is not only vast but also endlessly varied, filled with structures that are as surprising as they are beautiful. And in this gentle realization, we begin to see that strangeness in the universe is simply another form of harmony, one that unfolds slowly, patiently, and endlessly across the silent expanse of space. How strange galaxies take shape. Strange galaxies do not appear suddenly. Their unusual forms are the result of slow, patient processes that unfold across millions or even billions of years. To understand how they take shape, it is helpful to imagine the universe not as empty space, but as a quiet field of invisible forces, where gravity gently guides everything into motion. At the beginning of a galaxy's life, clouds of gas and dark matter begin to gather under the influence of gravity. Over time, these clouds collapse and form stars, gradually building a structured system. In most cases, this process leads to familiar shapes. But sometimes, subtle differences in motion, density, or environment cause the outcome to diverge, giving rise to something far more unusual. One of the most important factors in creating strange galaxies is interaction. Galaxies are not isolated, they exist in groups and clusters, slowly drifting through space. When two galaxies pass close to one another, their gravitational fields begin to interact. This interaction does not happen quickly. Instead, it unfolds like a slow cosmic dance, where each galaxy gently pulls on the other. As they move closer, their shapes begin to change. Spiral arms may stretch outward, forming long streams of stars known as tidal tails. Gas clouds can be compressed, triggering bursts of new star formation. In some cases, a bridge of stars and gas forms between the galaxies, connecting them in a delicate, luminous arc. If the interaction continues, the galaxies may eventually merge. This process can take hundreds of millions of years. During this time, their original structures are gradually lost, replaced by a new, often irregular shape. The result is a galaxy that carries traces of both of its predecessors, yet appears entirely unique. Not all strange galaxies are formed through collisions. Some arise from internal processes. At the center of most galaxies lies a supermassive black hole. When large amounts of matter fall into this region, it can release enormous energy, illuminating the galaxy's core. This activity can reshape the surrounding structure, creating bright, unusual features that stand out against the calm darkness of space. There are also galaxies influenced by their environment. In dense clusters, the gravitational pull of many nearby galaxies can distort a single system over time. Gas may be stripped away, leaving behind a faint and ghostly structure. These galaxies often appear quiet and dim, yet their forms tell a story of past interactions and gradual transformation. Time is the quiet architect behind all of these changes. What we see as a strange galaxy is often just one moment in a much longer evolution. A distorted shape today may become smooth and stable in the distant future. In this sense, strangeness is not permanent, it is part of an ongoing journey. Interestingly, even small differences at the beginning can lead to dramatically different outcomes. A slight variation in speed, direction, or mass can change the entire path of a galaxy's development. This sensitivity adds to the diversity we observe, ensuring that no two galaxies are ever exactly alike. As astronomers observe these processes, they are not watching them in real time, but through the light that has traveled across space. Each strange galaxy is a snapshot from the past, offering a glimpse into how these vast systems evolve. In a calm and almost poetic way, the formation of strange galaxies reveals a deeper truth about the universe. It is not rigid or uniform, but dynamic and ever-changing. Through gentle interactions, invisible forces, and the passage of time, galaxies transform, creating forms that are both unexpected and quietly beautiful. And so, strange galaxies are not anomalies to be explained away, but natural expressions of a universe that is constantly shaping itself, slowly, silently, and with endless variety. When strange galaxies reveal their light. Strange galaxies are not only defined by their shapes, but also by the way they shine. Their light, often soft and distant, carries quiet information about what is happening within them. To understand when strange galaxies reveal their most unusual qualities, we must look not at their form alone, but at the subtle variations in their brightness, color, and energy. Light in the universe travels across immense distances, taking millions or even billions of years to reach us. This means that when we observe a strange galaxy, we are seeing it as it was long ago. In many cases, the most unusual galaxies appear brightest during moments of change, periods when internal or external forces gently disturb their balance. One of the most striking examples occurs during bursts of star formation. In some strange galaxies, large clouds of gas collapse rapidly, forming new stars at an accelerated rate. These regions glow with a soft, bluish light, indicating the presence of young, hot stars. This phase does not last forever, but while it continues, the galaxy appears vibrant and full of quiet energy. There are also galaxies whose centers shine far more brightly than expected. At their core lies a supermassive black hole, surrounded by an accretion disk of heated matter. As this matter spirals inward, it releases energy in the form of light, sometimes outshining the rest of the galaxy. These active centers can create a calm yet powerful glow, radiating outward in all directions. In other cases, strange galaxies reveal themselves through what is missing rather than what is present. Some appear dim and diffuse, with very little star formation. Their light is soft and even, often redder in tone, suggesting an older population of stars. These galaxies seem quiet and still, yet their unusual structure hints at a more active past. The timing of these luminous phases is deeply connected to the life cycle of a galaxy. After an interaction or merger, a galaxy may enter a period of intense brightness as gas is compressed and new stars are formed. Over time, as this gas is used up or dispersed, the galaxy gradually dims, settling into a more stable and peaceful state. Dust also plays a gentle role in shaping how galaxies are seen. Fine particles of cosmic dust can absorb and scatter light, softening the appearance of bright regions and creating subtle variations in color. In some strange galaxies, this dust forms lanes and patterns that add to their unusual beauty, partially hiding what lies within. Interestingly, not all light from strange galaxies is visible to the human eye. Much of it exists in wavelengths such as infrared, ultraviolet, or radio waves. These forms of light reveal hidden processes, cool gas clouds, energetic particles, and structures that cannot be seen in ordinary light. By observing across different wavelengths, astronomers can build a more complete picture of these galaxies and understand when their most active phases occur. Time, once again, is central to this story. The brightness of a strange galaxy is not constant, but changes slowly as it evolves. What appears luminous today may fade over millions of years, while a quiet galaxy may one day brighten as new processes begin. In a calm and reflective sense, the light of strange galaxies is like a gentle signal, offering clues about their past and present. It tells us when they are active, when they are resting, and when they are in transition. Each variation in brightness is part of a larger rhythm, one that unfolds across the vast timescales of the universe. As we observe these distant sources of light, we are reminded that even in the quiet darkness of space, there is constant change. Strange galaxies do not simply exist. They evolve, brighten, and fade, revealing their nature not all at once, but gradually, through the soft language of light that travels patiently across the cosmos. Where strange galaxies exist in the universe. Strange galaxies are not confined to a single region of the universe. They appear in many different environments, from dense clusters filled with thousands of galaxies to the quiet, almost empty stretches of cosmic space. To understand where these unusual systems exist, it is helpful to imagine the universe as a vast web, an intricate structure of filaments, nodes, and voids, where galaxies are gently arranged by gravity over unimaginable distances. In the densest regions of this cosmic web lie galaxy clusters. These are immense gatherings where galaxies drift relatively close to one another. In such environments, interactions are more common. The gravitational pull between neighboring galaxies can distort their shapes, strip away gas, and trigger unusual activity. As a result, many strange galaxies are found in these crowded regions, their forms shaped by repeated encounters over time. Within clusters, there is often a central galaxy that stands out. These galaxies are typically much larger than the others and may have grown through multiple mergers. Their structure can appear smooth at first glance, but closer observation often reveals subtle irregularities, faint shells, ripples, or extended halos of stars. These features are quiet reminders of past interactions, preserved like gentle echoes in their form. Moving away from clusters, we enter smaller groups of galaxies. Here, the pace is slower, but interactions still occur. In these groups, galaxies may orbit one another over long periods, occasionally passing close enough to create tidal distortions. Strange galaxies in these regions often display elongated arms or asymmetric shapes, reflecting the influence of a nearby companion. There are also strange galaxies that exist in relative isolation. These galaxies are found in less populated areas of the universe, far from the crowded clusters. Their unusual nature is not always the result of interaction, but may arise from internal processes or unique initial conditions. Some of these isolated galaxies have odd shapes or unexpected brightness patterns that challenge simple explanations. Between the clusters and groups lie vast cosmic voids, regions where very few galaxies exist. These areas are quiet and expansive, with enormous distances separating each galaxy. While strange galaxies are less common here, those that do exist often appear particularly distinct. With fewer external influences, their unusual features may persist for longer periods, evolving slowly in isolation. The position of a galaxy within this cosmic structure influences its evolution. In dense regions, frequent interactions can lead to rapid and dramatic changes. In quieter areas, galaxies evolve more gently, shaped by internal dynamics rather than external forces. This variation in environment contributes to the diversity of strange galaxies observed across the universe. Interestingly, strange galaxies can also be found at great distances from us. Because light takes time to travel, observing distant galaxies allows astronomers to look back into the early universe. In these distant regions, strange and irregular galaxies are more common, suggesting that the universe itself was more dynamic and unsettled in its youth. The distribution of strange galaxies is therefore not random. It reflects the underlying structure of the universe and the history of its formation. By studying where these galaxies are located, astronomers gain insight into how matter is organized on the largest scales and how it has evolved over time. In a calm and expansive sense, the locations of strange galaxies remind us that the universe is both structured and open. Patterns exist, yet within those patterns there is room for variation and complexity. Whether in crowded clusters or quiet voids, strange galaxies find their place, each shaped by its surroundings and its history. As we continue to map the cosmos, more of these galaxies come into view, scattered across the vast web of space. And with each discovery, we deepen our understanding of not only where strange galaxies exist, but also how the universe itself is woven together, slowly, gracefully, and with infinite detail. Why strange galaxies matter. At first glance, strange galaxies may seem like distant curiosities, beautiful but unrelated to our everyday understanding of the universe. Yet, in a deeper and more meaningful sense, they play an essential role in helping us understand how everything around us came to be. Their unusual forms are not merely visual differences, they are quiet records of cosmic history, offering insight into the forces that shape all galaxies, including our own Milky Way. Strange galaxies matter because they reveal processes that are otherwise difficult to observe. In a typical, stable galaxy, many changes happen slowly and subtly, making them hard to detect. But in a strange galaxy, where interactions, distortions, or bursts of activity are more pronounced, these same processes become visible. It is as if the universe gently amplifies its behavior, allowing us to study it more clearly. One of the key reasons these galaxies are important lies in their connection to transformation. When galaxies collide or interact, they do not simply pass by unchanged. Their structures shift, their stars redistribute, and new stars may form in great numbers. By observing strange galaxies in different stages of interaction, astronomers can piece together the sequence of events that leads from one form to another. This understanding helps answer a fundamental question: how do galaxies evolve over time? The universe is not static. It changes continuously, though often at a pace too slow to notice directly. Strange galaxies provide snapshots of these changes, each one representing a different moment in a long evolutionary journey. They also offer insight into the role of dark matter, an invisible component that makes up most of the mass in galaxies. Although dark matter cannot be seen, its presence influences how galaxies move and interact. In strange galaxies, especially those that are distorted or stretched, these gravitational effects become more apparent. By studying their shapes and motions, scientists can infer how dark matter is distributed and how it behaves. Another important aspect is the study of extreme environments. Some strange galaxies contain highly active centers, where enormous amounts of energy are released. These regions can affect the entire galaxy, regulating star formation and shaping its future development. Understanding these processes helps scientists learn how energy flows through galaxies and how balance is eventually restored. Strange galaxies also help refine the tools and methods used in astronomy. Because they do not fit neatly into standard categories, they challenge existing models and encourage new ways of thinking. Each unusual observation invites deeper questions, leading to more accurate theories about how the universe operates. Interestingly, these galaxies can also serve as natural laboratories. Conditions that cannot be recreated on Earth, such as massive gravitational interactions or large-scale starbursts, occur naturally within them. By observing these environments from a distance, astronomers can study physical processes under extreme conditions, expanding our understanding of physics itself. There is also a quiet philosophical importance to strange galaxies. They remind us that the universe is not limited to simple patterns or predictable outcomes. Variation is not an exception. It is a fundamental characteristic of existence. In this way, strange galaxies broaden our perspective, encouraging us to see complexity and diversity as natural and essential. Even our own galaxy may have experienced periods of strangeness in the past. Evidence suggests that the Milky Way has interacted with smaller galaxies and continues to do so. These interactions, though subtle now, have helped shape its current structure. This connection brings a sense of closeness to what might otherwise feel distant and abstract. In a calm and reflective sense, strange galaxies matter because they tell stories of motion, change, and quiet transformation. They show us how the universe evolves, not in sudden leaps, but through continuous, gentle processes guided by gravity and time. As we study them, we are not only learning about distant objects, but also about the fundamental nature of the cosmos. Strange galaxies are not anomalies to be overlooked. They are essential pieces of a much larger picture, helping us understand where we come from and how the universe continues to unfold, slowly, endlessly, and with remarkable depth. The role of time in shaping strange galaxies. Time, in the universe, does not move with urgency. It unfolds slowly, almost imperceptibly, guiding the formation and transformation of galaxies across billions of years. When we observe strange galaxies, we are not simply seeing unusual shapes. We are witnessing moments within an immense timeline, where past events continue to influence the present. Every galaxy carries a history written in motion. Stars orbit their centers, gas drifts through vast regions, and invisible structures of dark matter provide a gravitational framework. Over time, even the smallest interactions accumulate, gradually altering the galaxy's form. What may appear as a sudden distortion is, in reality, the result of countless subtle changes unfolding over unimaginable durations. One of the most important ways time shapes strange galaxies is through interaction. When galaxies pass near one another, their gravitational influence begins immediately, but the visible effects take much longer to emerge. At first, the galaxies may seem unchanged. Then, slowly, their outer regions begin to stretch. Spiral arms extend, streams of stars form, and delicate distortions appear, each one a quiet sign of an ongoing process. As time continues, these interactions deepen. The galaxies may orbit each other for millions of years, gradually drawing closer. Eventually, they can merge, blending their structures into a new and often unfamiliar form. Even after the merger is complete, the resulting galaxy continues to evolve, smoothing out its irregularities and settling into a more stable state. Time also governs the life cycles of stars within these galaxies. In regions where gas is compressed, new stars are born, shining brightly for millions of years before fading. In other regions, older stars dominate, casting a softer, redder light. The balance between these populations changes slowly, influencing the overall appearance of the galaxy. There are moments in this timeline when a galaxy appears especially strange. These are often transitional phases, periods when the structure has been disturbed but not yet stabilized. Such phases can last for hundreds of millions of years, meaning that what we observe as unusual is actually a natural and extended stage of evolution. It is also important to remember that light itself carries the imprint of time. Because it travels at a finite speed, the light from distant galaxies reaches us long after it was emitted. When we look at a strange galaxy, we are seeing it as it existed in the past. Some of the most distant strange galaxies we observe today may no longer exist in the same form. In this way, astronomy becomes a study of time as much as space. Each observation is a glimpse into a different era, allowing scientists to reconstruct the sequence of events that shape galaxies. By comparing galaxies at various distances, it becomes possible to understand how strange forms emerge, evolve, and eventually transform. There is also a quiet balance between change and stability. While time introduces variation and transformation, it also allows systems to settle. After periods of disturbance, galaxies often return to more regular shapes. This gradual movement toward equilibrium is part of the natural rhythm of the universe. Interestingly, time does not act alone. It works in harmony with gravity, motion, and energy. Together, these forces create the conditions under which strange galaxies form and evolve. Time provides the stage upon which all these processes unfold, ensuring that even the most dramatic changes occur with a certain calm continuity. In a reflective sense, strange galaxies remind us that transformation is not immediate. It is the result of persistence, of forces acting gently but continuously over vast periods. Their unusual forms are not sudden anomalies, but expressions of time itself, visible traces of a universe that is always in motion, yet never in haste. As we continue to observe the cosmos, we deepen our understanding of this relationship between time and structure. Strange galaxies become more than distant objects. They become markers along a timeline that stretches far beyond human experience. And in this quiet awareness, we begin to see that the universe is not defined by moments, but by processes, slow, continuous, and endlessly unfolding across the depths of space and time. The most unusual types of strange galaxies. Among the many forms galaxies can take, some stand apart not only for their rarity, but for how profoundly they differ from what we expect. These are the most unusual types of strange galaxies, systems that seem to gently challenge the familiar patterns of cosmic structure, offering quiet examples of how diverse the universe can be. One of the most visually striking types is the ring galaxy. Instead of forming a spiral or elliptical shape, these galaxies appear as luminous circles, often with a sparse or nearly empty center. This structure is usually the result of a past collision, when a smaller galaxy passed directly through a larger one. The gravitational disturbance sends waves outward, compressing gas and forming stars in a circular pattern. The result is a calm, glowing ring suspended in space, like a ripple frozen in time. Another unusual form is the polar ring galaxy. In these systems, a ring of stars and gas orbits around the galaxy at a steep angle, sometimes nearly perpendicular to the main disk. This creates a graceful, almost geometric appearance, where two distinct structures coexist in a delicate balance. These galaxies are thought to form through the capture of material from another galaxy, or through past interactions that left matter orbiting in an unexpected direction. There are also galaxies known for their extreme brightness at the center. These are often referred to as active galaxies, where the core emits enormous amounts of energy. At the heart of such a galaxy lies a supermassive black hole, quietly drawing in matter. As this material spirals inward, it heats up and releases light, sometimes producing narrow jets that extend far beyond the galaxy itself. These features, though powerful, often appear smooth and steady when viewed from afar. In contrast, some strange galaxies are defined by how little they contain. Ultra-diffuse galaxies, for example, are large in size but contain relatively few stars. This makes them faint and difficult to detect, as their light is spread thinly across a wide area. Despite their quiet appearance, they may hold significant amounts of dark matter, giving them an unseen structure that maintains their shape. Another rare type includes galaxies with highly irregular or chaotic forms. These galaxies do not follow clear patterns and may appear fragmented or asymmetrical. Their structure often reflects a history of interactions, mergers, or internal processes that disrupted their original form. Yet even in their apparent disorder, there is a subtle harmony shaped by gravity and time. Some galaxies are also known for producing long streams of stars that extend far into space. These tidal features can stretch over vast distances, forming elegant arcs or trails. They are remnants of past interactions, slowly dispersing but still visible as faint, luminous traces. Observing these features allows astronomers to reconstruct events that occurred billions of years ago. There are even galaxies that appear almost invisible. These dark galaxies contain very few stars, making them difficult to observe directly. Their presence is often inferred through their gravitational effects on nearby objects. They remind us that not all galaxies are defined by light. Some exist quietly, hidden within the deeper structure of the universe. Each of these types represents a different path in the life of a galaxy. Some are shaped by collision, others by isolation, and still others by internal forces that gradually reshape their structure. What unites them is their departure from the expected, offering a wider view of what galaxies can become. In a calm and thoughtful way, these unusual galaxies expand our understanding of cosmic possibilities. They show that the universe does not follow a single pattern, but instead allows for a wide range of forms, each shaped by its own history and environment. As we continue to observe and classify these galaxies, new types may still be discovered, each one adding to the quiet diversity of the cosmos. And with every new observation, we are reminded that strangeness in the universe is not an exception. It is a natural expression of its endless complexity, unfolding slowly across space and time.